So if you recall, we had finished up last time talking about the various methods, some additional methods in Flux, including things like the create method that was used to create fluxes in more interesting ways. We talked about concurrency operations like subscribe on and publish on. We talked about the new parallel scheduler and other things along those lines. So we had a bunch of examples that we talked about that were more sophisticated. We talked about some more sophisticated suppression operators like filter and take and so on and so forth. So what we're going to do now is we're going to put all this stuff together in a really fun example. This is the ex2 project in my Reactor Flux folder in my Live Lessons GitHub repository. And we're going to show a bunch of different techniques that are used here. And we're also going to see how we can have this stuff run asynchronously. So before, the previous case study ran things synchronously. Now we're going to turn around and run these things asynchronously. And as usual, you can get this stuff at my website. So here we are in the ex2 project. And let's go ahead and take a look at the entry point driver program. This entry point driver program only has two methods that we're testing. One is called test is prime timed, and that's what we're going to look at first. And then we're going to take a look at test is prime async. And the way this works, as in all of our tests for this part of the course, we register these methods via their method reference names with the async task barrier, which is that cool barrier synchronizer. And once we register those things, we tell the async task barrier, please start running these tasks. Both of these tasks run asynchronously in the background, unlike the previous case study where they ran synchronously. So this is really going to be where the async task barrier pays off. So what it's going to do, those things are going to start running, and then we're going to block the main thread of control until they're all finished. And when they're all finished, we're going to go ahead and print out how many tests ran and exit the program. But that'll be after the other methods finish running. So let's go ahead and take a look here first at test is prime time. And before I do that, here's just a little bit of background on some fields that we define here in the Flux EX class. So we have max number of random values. We're going to have 10 million values. This is going to be doing prime number checking, because I like that one. And we got 10 million things to check. We're going to have, that's the maximum size of the random number, 10 million. And then we're going to do 10 iterations on this. And we're going to have the values between the max value and the max value minus max iteration, so we can get some duplicates in here. We're going to have something called a S prime cache, which is a memoizer that's going to map big integer to big integer. What it's going to do is it's going to use a concurrent hash map, and it's going to look up to see if we've already computed the primality of a given prime candidate. And if we have, we're just going to return the value that we stored in the cache. Otherwise, we're going to run a function to compute the value and store it in the cache for later use. That's why we wanted duplicate numbers. We have a random number generator that we allocate. We have a duration, which we're going to use here in a minute with our flux interval operator. So it's going to basically generate data every half a second. And then we define a couple of predicates. This predicate will only match odd numbers. So it'll only emit numbers that go through this predicate. So if the number modded by 2 equals 0 or does not equal 0 in this case, then that means it's an odd number. And then we're also finally going to have another function here, which is going to generate random integers. So it's going to take the lower bound and generate a random integer that's going to be from the lower bound up to the number of iterations that we're going to do here. So it's going to give us that many values. So generate a random big integer. And the goal here, again, is to generate duplicates. And I think that shouldn't be S max iterations. It should be S max value. Let me change that. S value. That looks better. OK, so now that we've got that, here is the method that's under test. Test is prime time. So the first thing we do is we make a string buffer. And we use a string buffer here because some of these computations are going to be running in background threads, and we don't want to have race conditions when trying to update the logging object that we've got here. Previously, when we did synchronous communication, we used string builder as opposed to string buffer. And we used string builder before because everything ran in one thread of control, whereas now we're doing things that can run in multiple threads of control, and we want to make sure that we don't end up with race conditions that can corrupt those values. And so that's an important thing to understand, is the difference between string builder and string buffer. So once we've made our little logging mechanism, we then define a callback, which is going to write the results to the string buffer, just because we can simplify some of the code here. And then we go in and we have this interesting Flux. And this is a really, really cool design. And it's going to use the create factory method operator that's defined on Flux. So here's what it's doing at a high level. We're going to go ahead and create something that will run in the background and will generate events. It'll generate events forever using the interval method. We'll look at that in a second. So it's called make timed flux sync. And then we're going to take the results of that, because remember, create is a factory method. We're going to take something that's coming out as a stream of fluxes, a flux stream of integers. And then we're going to log the next integer so we can keep track of them. Then we're going to go ahead and check to see if the integer is prime or not. And we're going to use this check if prime method. We'll look at that in more detail in a second. That's going to use this cool memoizer technique. And then whatever we get back from check if prime for each of these big integers, we're going to go ahead and basically print the results. So process results is just going to print out the results that we get back. And the way we end this whole chain, and this is important to remember, we're going to use that then operator. Remember, we talked about the then operator last class, and I talked about it, how it was a suppressing operator. And what then does is it basically says, when everything is done in the stream, then call this particular publisher and emit whatever it does, which in this case is just going to display the results. So we use the from runnable method of mono to display the results, and then that's going to return an empty mono back as the result for this method. So it's going to return a mono to void. And the mono to void is basically a trigger or a signal to the async task barrier that lets it know that this asynchronous computation has wrapped up. And therefore, it'll decrement its count of things it's waiting on. And when everybody's finished up, it will then return in the calling thread. So then is a very useful method to be able to have a side effect, which in this case is just to display the results, and also to inform the async task barrier that this computation is done. So that's what this particular little flux stream does. There's another one that's the inner flux stream that's generated by this factory method called make timed flux sync. And what make timed flux sync does is it's going to go ahead and it's going to have a call to the interval method on flux. Now, if you remember what interval was another factory method. And interval went ahead and would generate numbers starting at 0 forever at this periodicity. So basically, in this case, sleep duration is half a second. So we're saying every half second, generate a number starting from 0 to infinity. We don't actually care about those numbers, by the way. We just want something to be generated every half second for infinity. So what we do is we turn around, we ignore those values altogether, and we use the generate random big integer method here, which, if you recall, is just going to generate a random big integer within this range. And so what comes out every half second, a new random big integer will be generated within that range, which will include duplicates. And then we apply the filter suppressing operator to only allow odd numbers. What's the point of checking to see an even number is prime? We know it's not going to be prime, so let's not waste our time trying to do that. So we're only going to generate odd numbers, or only let them through. And then, because we don't want to do this forever, we're going to stop after S max iterations of big integers. So that's another suppressing operator. That says, generate 10 random big integers that are odd. And then we put at the bottom, because you always have to have subscribe to kind of keep things going, we say, if all goes well, emit that event up the stream to the outer stream from the inner stream. If something goes wrong, shut down. So those things are going to be used to shut stuff down. Let's see. So it looked like it wants that. There we go. OK. So that's that method. So let's go ahead and run this program. And if I have successfully propitiated the compiler gods, we will see results, and we do. And let's go take a look at those results. You'll see what we're seeing first is test is prime async. We'll come back and talk about that next. Here's the results from test is prime timed. So what's happening here is we're running in a background thread. Remember I told you that the interval operation ran in the parallel thread pool, parallel scheduler. So everything's coming out of the parallel pool. Parallel-1 is the thread. It's all coming out of the same thread. And this is the timestamp when stuff is happening. And if you look carefully here, it's basically every half a second. So we're emitting a random number. We're checking to see if the random number is prime. And if it is prime, we say we found the prime number. We emit another number, check to see if it's prime. Now we find a non-prime number with its smallest factor, and so on and so forth. And it'll keep doing this stuff. And what's happening here is whenever we find something that is a duplicate that we've already looked up, then we're going to have the memoizer will just return it without us having to go and perform the computation again. So let's just take a quick look at the memoizer, because that's kind of cool too. Let's pop back out of here. So here's check if prime. Check if prime takes a prime number candidate, and it makes a new record. A record is probably recall, a record is a Java type that only contains data. So it's got the prime number that we're looking for, the prime candidate, and the result, which is either the smallest factor if it's non-prime or 0 if it's prime. And what we're doing here is we're using a very cool atomic check then act method that's defined on the concurrent hash map in Java called compute if absent. What compute if absent does is it says, here's a key, the prime candidate, and it says, if we've already looked up the value of this, if we've already computed the value of this key, and the value's sitting in my concurrent hash map data structure, return that value, you're done. That's the happy path. However, if it's the first time we've tried to see if this number is prime, then what it's going to do is it's going to go ahead and call this function. And this function is mapped to the isPrime method. And I think you can imagine what the isPrime method does. I'm just going to show it to you just for completeness. But basically, it just checks to see whether or not a big integer is prime. So nothing magic about that. And that'll return either 0 if it's prime or its smallest factor if it's not prime. This method, when called, will return a result, and that result will be stored in the concurrent hash map with this key. So that result will become the value for this key. And this whole operation is what's called an atomic check then act operation or instruction, computation. And what it does is it will atomically check to see if the value is in the map, and if not, it'll atomically call this method, and if it gets a result back, or when it gets a result back, it will atomically update the map. That all takes place atomically, so you don't have to worry about race conditions. You don't have to worry about this method being called multiple times. There's some really, really clever ways it's done. I'm not going to go through that right now. That's outside the scope of this talk. But that's what check if prime does, and that's what's called a memoizer. So knowing what a memoizer is probably something you should be aware of, because we're going to talk about that in many different contexts. So that's this particular implementation illustrating how that all works.